You can train your robots in the virtual world to be better robots in the real world. Omniverse is a future. It's the bicycle of imagination. Steve Jobs called computer bicycle of mind.
What is the metaverse? Michael Kagan, the Chief Technology Officer of NVIDIA, explains.
I started my career at Intel, where I was designing the microprocessors. The first processor that I was architect of was 860XP, which was the great vector machine, which is a little bit ahead of its time, and no software support, so it vanished. Then I managed Pentium MMX design. This was the program that actually brought CPU design to Intel in Israel. And in '99, I joined a small team of people to fund Mellanox, start Mellanox Technologies, which is the high-performance network. We were doing high-performance networking. And after 20 years, NVIDIA acquired Mellanox. And for me, it was a great closing the circle, because NVIDIA is doing the state-of-the-art vector processors, but they do have all the right software system and ecosystem support. And I'm a lucky one to be Chief Technology Officer at NVIDIA. And actually, my charter is to architect across the wealth of NVIDIA technologies. It's NVIDIA, I think it's the most technological company I ever seen, I ever worked with. And it's an amazing opportunity to basically build the computing of the 21st century. And that's what my job as the CTO of NVIDIA, to architect across technologies.
NVIDIA is very involved with what people call the metaverse, and NVIDIA calls the omniverse. So when we talk about the metaverse or the omniverse, what is it?
Metaverse is the virtual world. It's the world where you can make your fairy tale come true. It's and Omniverse is an implementation of this idea. So you can create virtual world, you can live in virtual world, you can collaborate in virtual world across the globe with no boundaries of geographical boundaries or limitations, or even language boundaries. You can work together. You can connect this virtual world to real world. And you basically can make your fantasy come through. And one of the projects that we are embarking on at NVIDIA is we are doing the simulation of real world of the Earth. And basically, with the Omniverse, you can make history to be experimental science. You can simulate what will happen in the future. For example, how do we handle global warming? And how do we handle climate changes? So, making fantasies come through and making fairy tales is great, but what you can also do, you can actually simulate large projects before you build them. You may have heard that large car manufacturers like BMW are working with us. They're actually simulating their large project before they build it. And once we build something, you can have a digital twin of this project, be it data center, be it manufacturing plant, be it smart city, and you can have an interaction of this digital twin with its real twin, and you can train your robots in the virtual world to be better robots in the real world. So Omniverse is a future. It's the bicycle of imagination. Steve Jobs called computer bicycle of mind. Omniverse is a bicycle of imagination.
Is it accurate to say that the metaverse, or your implementation of it, the Omniverse, is a digital twin? Are we talking about an elaborate digital twin? I think many of us are familiar with the concept of a digital twin in manufacturing. So is this the next evolution? Where do they fit together?
It can be exactly the digital twin, as you mentioned. It can be digital twin at much higher scale, and it can be a virtual world which starts with digital twin, and then you evolve it further and basically try out what will happen in the real world by simulating it in the Omniverse. So you can, and this digital twin can actually interact with its real counterpart. So you can get the sensors data. You can stream into the digital twin and simulate what's going to happen and how to respond and how to react, be it good or bad.
What are the components of constructing the metaverse or your implementation, the Omniverse? You are a chip designer and you're looking across you're looking at technologies across NVIDIA. So behind the scenes, what do we need to make this happen?
Omniverse is a tool to collaborate and to cooperate. It's you create a virtual world in the data center that simulates it can have an accurate simulations of physics, and there is interfaces that you can connect to this virtual world and make changes, updates. You can work on your projects from multiple places through multiple plugins. And there is a great tutorials and great presentations on the technical details on the Omniverse and the GTC. So whoever is interested to get some specific details, it's welcome to see the GTC recordings.
What are the foundations? I know you're working on microprocessors. NVIDIA obviously creates GPUs. So what are the pieces that must come together? You have the data in order to build this kind of simulation.
It's an accelerated computing platform that is capable of simulating very large projects. It's a lot of data that feeds this platform, and actually this is accelerated platform that processes the data based on the AI models that were trained on in real world on sometimes on the simulated data. There is the laws of physics that we simulate in AI that actually cannot be simulated in the sequential machines, human machines. So in order to have such a simulation, you need to have a data center scale computer, and you need to have a right infrastructure to accelerate the AI-based data processing.
Why AI? Where does AI fit into this?
AI is the new way of processing the data. If you look at the traditional way of programming the computers on human machines, you basically write the program, and it's like explaining somebody what to do, and then computer does what you have done. The thing is that we cannot explain, or we don't know how to explain different things. Things we just can't explain. You can't explain how to distinguish between cat and dog. You can't explain how to distinguish between man and woman. But kids know how to. You show kid the dog and you show him the cat, and he will know which one is which. And the way it's done because he learned from examples. So the analogy here is that this AI is basically not human writing software, but software writing software. You give the computer. You teach the computer on the examples. You teach this. You feed the neural network model, the AI model, with the lot of data from the real world, and this training process results of computer of this model being able to simulate physical phenomena like in fluid dynamics that you cannot simulate on the real computer.
So you are taking this notion of simulation and then extending it out to a very far degree. Again, is this an accurate, although very simplistic way of looking at what's going on?
You can look at this way. We simulate the real world, and we can make changes. And this Omniverse enables you to trial and error what will happen in the real world if you try it in the virtual world.
Where do you get the data from in order to make this possible? If you're simulating the real world and you have a jet engine, well, you know the properties of that jet engine. But if you're simulating if you're running a virtual environment, for example, where is the data coming from?
There is a lot of data that is available out there. We have our own sensors, like in our data centers, or in the NVIDIA has the fleet of cars that are running there collecting data. And once we have this model of the virtual world, we actually can generate data, and we can generate data that is either hard or very rare condition on the outside. Like, if you want to train your autonomous vehicle fleet to handle hazardous conditions on the road, you can get that much information from the real sensors or real cameras on the road. But in the virtual world, you can simulate hazardous conditions, and using the simulations, you can train your fleet of the cars to handle them. If you build infrastructure that needs to sustain earthquake, you can simulate earthquake. You don't need to wait for earthquake to get this data. So once you have a physically accurate model or ability to simulate physically accurate simulations, you can generate data by yourself. And this way you can actually have this federated training that, more data you generate, the better models, the better your models are trained, and the better then you have this better solutions, and basically you're building the better world.
Right now, there's a tweet chat taking place. You can ask your questions for Michael Kagan. He's the CTO of NVIDIA. When else will you have this opportunity? So ask your questions on Twitter using the hashtag CXOTalk. If you are watching on LinkedIn, just push your questions into the chat and you can ask whatever you like. And we'll turn to questions in just a couple of minutes. But Michael, you mentioned this concept of federated learning, and you referenced autonomous vehicles. So where do these concepts now fit into the metaverse?
Actually, everything that moves is autonomous. And the reason it's autonomous or will be autonomous, because when you move, you need to make a decision. And you need to make a decision, you cannot rely on the decision being made for you somewhere. So you need to make a decision. It means that everything that moves will have an AI model that helps him to make the decision and respond to the conditions that are happening. And these decisions is actually yet another learning. So, in the morning, there is a fleet of cars going out there, driving, making decisions, learning something. And then by the end of the day, they come back to the parking, and they actually feed this, everything that they learned, each one of them, they feed it back to the data center. And this data center consolidates all these learnings and basically updates the model for the cars, and then updates the cars with the new model, which is now much basically integrating the learnings from all other cars that were running that day. So you have some sort of perpetual learning at much higher rate than before. It's look at just an example. There's in the old world, emperors were sending explorers to explore the world, and they were coming back, a few years later, and now it happens momentarily. So all this experience of the autonomous vehicles or robots that are out there are being consolidated, and everyone gets update of everyone else's learnings.
Let's take a few questions from Twitter and LinkedIn. Let's jump first to LinkedIn. And Suman Kumar Chandra asks, how far are we from the metaverse being in prime time? And is this going to be limited to the technologically advanced community only? So in other words, When will ordinary people get a chance to experience this and the benefits?
In terms of technology advancement, the idea is that everybody will be able to connect to this virtual world and live in this virtual world. There's developers, there are users, and if you look at the evolution of computing and the data processing, at the very beginning you had to read very large books in order to operate the computer. And today you buy iPhone or Android machine. There's no even manual there. Just everything is intuitive. It takes a lot of engineering and a lot of smart people to make it work this way, but then everybody can consume it. Starting from 3 years old kids, and you don't need to be expert in the subject to consume it and to take advantage of this. The same with the Omniverse. We will live in this virtual world that will have an interface to everybody, and everybody will be able to be part of it. Developers is one thing, the users are other things, and there will be, you can sell things there, you can buy things there, you can live there.
We have another question now. This is from Twitter, and Adam Martin asks, in regard to NVIDIA's Omniverse, what do you think the largest benefit will be for companies in the architectural and engineering space? And how should companies be using it today?
The Omniverse enables you to simulate large projects. You can leave it before you build it. In the chip design, we simulate devices to make sure that they work once we manufacture them. If you build a large plane, or you project the city, you can simulate it on the conventional machines. But Omniverse enables you to simulate the city. If you put antennas for cellular communication, you can simulate where to place these antennas, including the signal reflection from the buildings. So you can basically simulate the very large projects. And I think in the near future, you are not going to build anything without simulating it first, because by simulating you can build much more sophisticated projects. And if you simulate them before you build them, then it will most likely work at the first shot. Otherwise, it's a huge amount of money you spend building the large plants that are not working at the end because there was some mistake on the way. So you can think about Omniverse is the ability to simulate every project that you build. And one of the big projects that we are, the humanity is there, is the climate. And I mentioned before, we are building the computer that will enable to simulate the entire Earth. So it's all the way up there, way beyond the plant or city simulation.
How is this different from the conventional notion of a digital twin that's used today in manufacturing, all kinds of different purposes?
Digital twin is a twin of something that exists. The digital twin, the twin of the real twin. You can start from the digital twin, but then you can change it to what you want to make the real plant or real world to be, and basically creating a digital twin of the real twin that was not built yet. And you can see whether this model fits your needs, whether it makes sense, whether it's economical, efficient, and then you can build it.
Say that one more time. The digital twin of the twin that was of the model that was not yet built.
You can start with creating a digital twin of something that exists, and then you can apply some inputs on this digital twin that do not exist, or either very rare in the real world, and then you can see how does this twin react, and then how does it respond, and then you can basically advance your real real world to do what you wanted to do and what you simulated in the digital world.
If you're listening, you should be asking questions. I mean, when else are you going to get the chance to ask Michael Kagan whatever you want about digital twins and the metaverse and the omniverse? And this is from LinkedIn, and Christopher Jablonski says, once adopted on a mass scale, how will the metaverse be used in combination with augmented reality, wearables, conversational computing, and smartphones? Or will it be largely mutually exclusive and overtake existing paradigms? So he's asking where this is all going to be going.
We are making more and more out of the real world to be able to be simulated. And whatever used to be mystery before now becomes the technical problem that we need to solve. And the augmented reality is sort of it's a micro virtual world. You take this glasses or whatever you have for augmented reality, and you use it, and you see some adjustments in the reality, but you can go much further, because you can basically try to foresee what's going to happen if something happens in the real world. You can see what will happen in your neighborhood if there is a volcano erupts nearby. You can simulate it.
We have another question from Twitter, and this is from Arslan Khan, and Arslan's a regular listener and always asks such good questions. And he says, the metaverse requires a lot of collaboration to acquire and share data. What if companies are not willing to share this data? Maybe they don't want to share their autonomous car driving data. What happens then?
Whatever is based on data and whatever is based on sharing the data, of course, you cannot take advantage of this if you don't have the data. So, and around the data, there has always been this question and this anxiety about confidentiality. Now, not everything you need to know in order to make things right, and not everything is really confidential. But if somebody doesn't want to share his data, he will not share the data, and therefore this model will not take advantage of this data. Of course, he can have his own, be it on premises or in the cloud, his own protected model that will be fed with the data that he is willing to use in this model, and he will create his own virtual world with his own data.
What about the cloud? Where is the intersection between the cloud and these virtual worlds, metaverse, omniverse, data centers? How does that piece together?
Cloud computing and the cloud in general is making the services, computing and the storage being at the service. It is sort of, it's the basic generation. It's like we have, everybody has electricity at home because there is large electric plants that are generating this electricity and deliver this power to everyone. Based on this, you can build a lot of things. And in this analogy, you need that much compute power to build the virtual world model. And you will need this power plant or data center to host this virtual world. And this virtual world will be connected to the clients or to different people that will live in this world, and then they will feed the data. They will consume the data. You can think about Waze as the micro virtual world of traffic. Here we have people that use Waze and they collaborate with each other. They actually create this notion or this world, this model and this data of the real-time traffic on the road, and they use it and they actually work with each other. They collaborate without even knowing each other, by sharing the data and letting this data center, the Waze service in the data center, to consolidate the data and to use it to steer the traffic. And you can take this from this example. You can go pretty much everywhere, and it can be in the social, it can be in the smart cities, it can be everywhere. So there is a data that's coming to the data center that's being consolidates it, builds the model, and updates or lets people to consume this new model and new world of this, basically this new situation.
So you're saying Waze is an example of people coming together, collaborating, even though they're not necessarily aware that they are collaborating, and creating a specialized virtual world for themselves for that period of time in which they are connected using Waze.
Yeah, Waze is an example of nano-virtual world of traffic that's of interest for me, where I am. The most amazing thing about Waze, that's why I like this example, is that there is millions of people, they collaborating with each other implicitly, and they benefit of this collaboration. And it could only be enabled by this technology that has ability to collect data from millions of sensors, consolidate it, and send back the insights.
This is kind of a metaphysical question. Is the virtual world created by Waze a temporary virtual world? After all, it's going on and on and on from the Waze standpoint, but for me as a driver, it's very temporary.
There's a basic things that, and actually Waze learns the stuff, and there is a momentarily condition of the road right now. But you can ask Waze, that I want to be in this particular place, 2 days from now at 5 o'clock in the evening when I need to leave my home. Okay, and how would you know that when I need to leave home? It's because it's already collected data. It already has an experience of what's going on the roads, and it can give you a fairly accurate prediction of when you need to leave your home to be at the office or at the theater at 5 o'clock in the evening.
If we go back to the data center again, so is it powerful computing, powerful storage, and data? Are those the building blocks that are required to make this happen?
Actually, data center is a computer on its own. You can think about this that was what we used to have. What we used to call a computer is a box under the table, or some some bigger box that is in the room. But today, data center is the computer. It's like a power plant. Okay, we have a single unit of computing that is delivering services to billions of users, and it requires communication. It requires computing. It requires computing acceleration. And it requires a lot of data, and it learns all the time.
Sounds like when the machine overlords take over, it's going to be the data centers that do it.
You can always get scared. Some people at some point people got scared about cars, then about the planes, and then about other things. Of course, there is a way that bad guys will take advantage of the technology, and you need to be aware of it, and you need to react. By the way, that's why yet another use of, or yet another advantage of having digital twin, for example, of the data center. You can simulate the cyber attacks, and you can be prepared to respond to cyber attacks. Now, machine taking advantage of people. Today it's a human machine team. Okay, the machine can process the amount of data that no human can process, and it can generate insights no human can generate, and human can make a decision that no machine can make. and they just work together.
We have some really interesting questions coming up on Twitter. And Arsalan Khan comes back and he says, do you think fiat currencies must become digital because of the metaverse, because we'll have to use cryptocurrencies in the metaverse for consumers? So he's asking about the impact on currency of the metaverse as it becomes more broadly used.
In some sense, it's analogy to the electricity. At some point, the currency was, this real gold medals or pieces of gold that people were carrying with them. Today, currency is some, virtual spreadsheet or some virtual table that is in there in the bank. You go to the store, you sign some paper, and there are some number moves from one table to another in the bank, and you go out with a car from the store or some other thing. Okay, so the currency and the money becomes more and more sort of abstract. And I was thinking that money is the currency is sort of analogous to the electricity. Electric energy, it worth nothing by itself. But using the energy, you can do pretty much everything you want. And I think this is what is happening with the currency. Right now, there's currencies that are associated with the countries, and there's a different exchange rates. I don't know how far it will hold. And it will be interesting to see how this evolves with the virtual world, with the virtual currencies. So I don't have my crystal ball to tell you exactly what's going to happen, but I think that if you look at the evolution of the currency and the money and the finances getting more and more sort of abstract and being some sort of a surrogate that you can use to build to consume it and to make various things.
Just another reminder to folks listening, if you haven't asked questions, well, you should be asking when else are you going to get to ask Michael Kagan? He's the CTO of NVIDIA, whatever you want. So, you guys should be asking questions. So we have an interesting question from Rogan Robert, and he says he is the innovation lead at Mazars London. He says, can you share some insights on any exciting firm-wide transformation projects that you have executed recently?
Indeed, is the wealth of technologies. It's we are accelerating the computing. If you look at the computing acceleration that was based on Moore law, it was 2x about every other year. In the last 20 years, the computing is 2x every year. And that's because there is much more innovation on the top of the computer stack. It's not just at the bottom on the process technology. So some people refer it as Wang law. Jensen Huang, it's our CEO, he made this observation and prediction that accelerated computing will improve the performance by 2x every year, and that's what's happening in the last 20 years. So making all these things to work together, it's amazing, and more compute power we build, it's more consumed, and actually it creates even more demand for more compute power.
What about the issue of heat? I can tell you, so I, of course, deal with a lot of video, and I have the latest and greatest Intel chip and the highest end NVIDIA graphics card. And my office becomes super hot, and heat is a real issue. So what about the heat issue? I'll ask you to answer that really quickly, because we're going to run out of time.
Well, that is an issue, and we are developing and deploying various technologies to handle it. But it is an issue, and actually, it's one of the things on the top of the list and the design technology, how to handle it and how to basically improve it.
Okay, we have another question from Twitter, and this is a really interesting one, and it is from Elizabeth Shaw. And she says, how will the metaverse and omniverse architectures change the architectures of distributed computing and data storage? So she's asking about the impact of metaverse and omniverse on the architecture of distributed computing and storage.
You don't need to go that far to metaverse and omniverse. The distributed computing, it started with this high performance computing, and now the data centers are built as the cloud native supercomputer. And this is the basic infrastructure that's based on fast data processing engines, which is a GPU. There's basically three pillars there. There's a CPU for framework, to run the application framework, GPU that actually crunches the data, and DPU, which is data processing unit, that is the infrastructure computing platform running operating system of this big machine. So it's changing today, and the Omniverse is one of the big consumers of this computing technology.
Can you describe for us the implications for business people? We have business people who watch this show, listening to this, and is very, very technology centric. What are the implications for those of us in business?
You can try everything. You can try everything out before you build it, or before you try to exercise it in the real life. So for business people, you can start making it. It will have clear implications on your business. And it will be in the heart of the business, this virtual world, that you can try it out, and you can simulate what you want to do, and you can simulate the results ahead of time.
And we have Arsalan Khan comes back again with a really, really interesting question. Again, it's kind of getting metaphysical here. He says, will the metaverse have a government? Who controls it? How will people get elected? So if the metaverse is a world, how is it managed?
That's an interesting question, because I'm also interested to know the answer. So we'll have to just leave it and see.
Michael Kagan, any final thoughts before we finish up?
Not to be encumbered with this past history or some limitations that we impose on ourselves. It's new technologies will do amazing things for us. And be optimistic. Computers will not take over humanity.
And I have one final question that I've been curious about for many years. In business, technology projects, before they go live, we all know can fail, have trouble, what have you. And when you're designing microprocessors, how do you, with billions and billions of transistors and at huge scale, how do you make sure that when you ship the thing out the door, this complex thing actually works?
Simulating a chip is like little Omniverse. We are doing the simulations and simulating everything that we are building.
You don't go to bed at night sometimes and suddenly wake up and realize, oh my God, we had this horrible flaw that we haven't picked up, and the thing is about to ship, or it's just shipped. That doesn't happen.
I wouldn't say, when you tape out the chip, and I'm in this business almost 40 years, and it's every time it's you have this concerns and afraid that it will not work. You know that you have done everything that you know how to do before you send the database to manufacturing, and you always miss a bit when chips comes back, and all of a sudden it starts working.
And with that, Michael Kagan, Chief Technology Officer of NVIDIA, thank you so much for taking the time to share all this interesting knowledge with us. I really, really appreciate your being here.
Thank you very much.
And thank you to everybody who watched. It's been a very, very fast 45 minutes. Before you go, please subscribe to our YouTube channel. Hit the subscribe button at the top of our website so we can send you updates on these live shows, and tell people so we can get people to ask questions like you guys have been doing. Thanks so much, everybody. I hope you have a great day, and we will see you again next time.